Voice test 1111. Let's see. I think we should be live now. Let me check. Click on this. Open. Voice test 1111. Let's see. I think we should be live now. Let me check. Click on this. Okay. So I think we're live and Daytain has opened up. So let's see. Let's see what it looks like. Okay. Everything's stable. Yeah, I think it is. Okay. Just across the hall, you find a large factory. Fortunately, the elves here have plenty of time to decorate. Unfortunately, it's because the factory machines are all offline, and none of the elves can figure out the initialization procedure. The elves do have the manual for the machines, but the section detailing the initialization procedure was eaten by a Shiba Inu. All the remains of the manual are some indicator light diagrams, button wiring schematics, and voltage requirements for each machine. All that remains of the manual are some indicator light diagrams, button wiring schematics, and voltage requirements for each machine. For example, we have some sequence of 313. The manual describes one machine per line. Each line contains a single indicator light, a single indicator light diagram in square brackets, one or more button wiring schematics in parentheses, and voltage requirements in curly braces. Okay. To start a machine, its indicator lights must match those shown in the diagram, where dot means off and pound means on. The machine has the machine has the number of indicator lights shown, but its indicator lights are all initially off. So an indicator light diagram means that the machine has 4 indicator lights which are initially off, and the goal is to simultaneously configure the first light to be off, the second light to be on, the third to be on, and the fourth to be off. You can toggle the state of um, indicator lights by pushing any of the listed buttons. By pushing any of each button lists, so square brackets or button wirings. Okay, each button lists where indicator lights. Each button lists which indicator light it toggles, where 0 means the first light, 1 means the second, and so on. When you push a button, each listed indicator light either turns on if it was off or turns off if it was on. You have to push each button on an integer number of times. There is no such thing as 0.5 presses, nor can you push a button a negative number of times. Why did they specify this? Okay, so a button wiring schematic like 034 means that each time you push that button, the first, fourth, and fifth indicator lights would all toggle between on and off. If the indicator lights were pushing the button would change them to be instead. Okay, so we turned off the zeros position 1, we turned on the third position 1 and 4. Okay, because one of the machines are running, the voltage requirements are irrelevant. Because none of the machines are running, the voltage requirements are irrelevant and can be safely ignored. Okay, you can push, I guess that's gonna be part 2, or you can push each button as many times as you like. However, to save on time, you will need to determine the fewest total presses required to correctly configure all indicator lights for all machines in your list. There are a few ways to correctly configure the first machine. You could press the first three buttons, one each, a total of three presses. You could press 1 3 once, 2 3 once, and 0 1 once, 0 1 twice, a total of 4 presses. You could press all of the buttons except 1 3 1 each, except 1 3 1 each, a total of 5 presses once each. Okay. Okay, however, the fewest buttons, the fewest button presses required is 2. One way to do this is by pressing the last two buttons, 0 2 and 0 1. Okay, once each. The second machine can be configured with as few as 3 button presses. Okay, one way to achieve this is by pressing the last 3 buttons. So okay, let me go up here. I think I just lost some information. No, I thought you 0 means that each time you push that button, the further forward. And then I guess this is one button, and this button will change. Okay, maybe we'll have to work through that. Okay. The second machine can be configured with as few as 3 buttons. There's 3 button presses. 0 1 2 and 1 2 3 4. Okay, yep. The third machine has a total of 6 indicator lights that need to be configured correctly. Okay, the fewest process required to correctly configure it is 2. One way to do it by pressing 0 3 4 and 0 1 2 3. Okay, the fewest button presses required to correctly configure the indicator lights on all of the machines is 2. Analyze each machine's indicator light diagram and button wiring schematics. What is the fewest button presses required to correctly configure the indicator lights on all the machines? Okay. I haven't come up with an algorithm yet for this one, so I don't know what we can do. Maybe we take an infinite permutations of the lists, because oh no, we it could end up being like that. Just the first two of them or one of them is enough, right? Permutations of all the button sequences. I think maybe something like that. That doesn't make sense, but maybe we I guess this will depend on how many, like what our target sequence is. Like how we iterate the list or the combinations we create will depend on what the pattern of what's the pattern of lights we want to create. We know this one will turn on the second one, the third one. Then firstly we should create the final state we need to achieve, and then I guess that's we already have that, and then loop over like some kind of combinations of these ones, but or maybe create and then loop over some combination of all of them and find the one that produces this pattern, and then all of them will start off with like I think do all of them have the same number of lights? No, they don't. No, they don't have that. We just I think compare it with this one. Compare our final with this one. What does our actual input look like? Oh, it's been 36 minutes. Yeah, it's 16 minutes while I was reading the problem. Okay, let's set up the project then. Make directory die 09. No, make directory die 10. Let's go into day 10 cargo new part 1. Let's go into part 1. Let's go into source domain rs, and then it's going to day 10 cargo run. And then part 1, then cargo run. Okay, that should work. That's working correctly. Let's go back here. Okay, so let's take our input, make directory inputs, go into inputs, example, inputs.example.text, and let's take this out. So finally we need to configure, we need to do the, so the fewest button presses required correctly to achieve it. We sum it up, I guess. There's maybe I'm thinking of my solution is gonna be brute forcing it, but I feel like that's not gonna be the right way to do it. I guess for each one we can go ahead and like we can, if we start with this one for example, we can see if that should be like the first one or not. We can see if like that makes sense as the first as the first as the first as the first like button press we do, because like if it turns on, I guess it could be that the, like for example in this one maybe we turn on some of them with the first one and then we turn them off with the second one, but since that one has more combinations or more lights it can modify, so that will end up being correct. Maybe I think we have to, I don't know, I think we have to brute force it. I don't know. Let's get the input, let input equals include star inputs comma example dot text. Let's save that. This has to be dot dot dot. And then let's go back here. Let's get the input. Let's save it. Yep. Close that. Move to inputs. Go look into inputs. Yep. Let's look at what we have. Which is correct. I think we're just gonna do this. Should we create a gnome parser for this? It's gonna be we can do that. We can add cargo add gnome. We can say struct button, which is gonna be, I guess, let's say button press is gonna be on a wake of the user32, and we have a struct machine which will have the let me call it indicate, I guess, lights, which is gonna be the string we want to create this string, and the wake of buttons wake of buttons, and then we have like the junctions. Let's also parse that out, but yeah, we're not gonna be using that now, so it'll be. So let's create a function parse button. I think that forgot about this, how do you define a nom parser? Nom. Let me just clear this out. It's like this, okay. It's like we have the input and we return an iResult, which will be the string, and then the output will be the button. And then there is a list of combinators. Not recipes, but it's going to guides. Oh, choose a combinator guide, that's what I wanted. Why is it prompting me for that now? I don't want to do it now. You chose the wrong time to do this, to ask me this. Okay, so what we want is a separated pair, or no, not a separated pair, but a delimited, something that's delimited by separated pair only parse out two values, and then what their separator is, and then what we need is a delimited, and then many optionally by like integers that are optionally followed by a comma. I think that's what we want. So this is gonna be like something like this. So yeah, something like this. Delimited, and it's delimited by the character. It's gonna be limited by a character parentheses. By this side, on the other side, it's gonna be delimited by a closing parentheses. And then we will have many I guess we'll have at least one in there, so let's say only one, and then each parser is going to be what are the parsers for numbers. Do we have a useRT2 parser? Configurable endianness, I think we do, I'm not sure though. useRT2, yeah, we do have that, and then it will take a useRT2 from the complete Streaming U32 recognize an unsigned 4-bit. No, that's not what we want. Where is this coming from? No, it's not what we want. It's not what we want. I guess we can say it's is digit or something. Yeah, we have to do is digit. Many while take is digit, or recognize a 0 or more numerical digit. What we need to recognize is a number, which is, yeah, I guess it's always I don't see it. Yeah, it's always less than 10. As you can see, I think it doesn't. It's always less than 10. I don't see it anywhere that is not greater than that, but in that case we need to have a take U32 kind of thing where it's gonna be an input and there's gonna be a result. There's gonna be another str, and but it's just gonna be U32, and then we say take U32. Where is that coming from? Not take while take. I guess we can say take we can say take till. No, take while. I guess take while, and then is digit. Didn't they have that here? Digit is digit 1 or is digit. Take while is digit. Maybe it's part is located behind a feature flag. No, not here. Here, feature flags. Parse U32 string. No. That's not how it works. You're wrong. Nope, not binary, but yeah, somebody's using it for AOC. Event of code. How are they parsing out the numbers in here? Parse section character complete U32. Well, I was trying to use that. That's not gonna do what we want, is it? Okay, it is what we want. In that case, we can say many, and then this is gonna be a pair or an optional pair. What was it? Pair. Say parted list, tuple, a pair, right? It's gonna be a pair. Let's disable the hinting false, followed by U32. Okay, I guess the code. Let's paste that in. U32 like that. followed by an optional character, which is gonna be a comma. Or it's gonna be in the middle of it is gonna be a separated separated list. Instead of a many, we can use a separated list one, and that's separated by this. Parse. Let's do to do here, and let's call parse on the input. Okay, we're having some parentheses problems. Like that. Okay, that one has it. Oh, the first one is the separator. It's gonna be a vehicle vis-a-vis. Exactly what we want. Call this traces, and we will return an OK, comma. I guess we need to return the input too. Oh no, let's go. And button. expected. Okay, I think this is it. This is the parse button function, and then what we need is a parse buttons situation, or we need to just create a parse machines, I guess. Parse machine I and str and I result str machine. Let's first parse out the let's do what I started to do here, and let's first parse out the target lights. So it's gonna be, this is gonna be input comma lights, I guess I comma lights, and equals, this is gonna be a delimited just like the last ones, but it's gonna be delimited by different character now. It's gonna be like that. This car. Okay, we're gonna call parse on input here, but what's inside, so it's gonna be just gonna be a string, I guess. It's the full string. Give me the full string. So there's just a string here. String. Find substring, or like any, or a sequence of my any I guess no much anything within brackets. So good pattern. Okay, so is not okay. Is it like a no, this is take while guess what are we getting in here? X is equals to dot, or x is equal to pound. Okay, now let's take our lights. So we have our lights, and the next thing we need to parse is the buttons, which are gonna be a sequence of, I guess we can take out the first empty yeah, and then do that. So we can maybe let's parse this out to parse lights, which will return a string okay, return an I comma lights dot to on. And then parse machine is gonna use that, and it's gonna say we want a separated no, I guess we also have this thing, so it's gonna be a tuple. Alright, in that case let's create that first thing, function parse, but that's gonna be very nearly identical to that, so let's copy this. Instead of doing that, let's do parse junctions. It's gonna be parse junctions, but it's not delimited by, this is delimited by that. No, it's delimited by curlies, and separated by commas. Make sense? Okay, so this is gonna return, instead of a button, it's gonna return just a process, and this is gonna be, let's rename this to junctions, and junctions are a wake of U32. Okay, and then here we can say we are going to produce a I comma something, but it's gonna be a tuple. Tuple is okay, tuple is deprecated. Oh, I guess since tuple, they deprecated tuple because this is a valid parser now, I think. If I remember correctly, parse. So it's gonna be parse lights followed by character, no, I guess a space 1, and then parse buttons, no, I guess parse button, but applied at least many, then another space 1 followed by a parse junction, and we can call dot parse on this whole thing. Let's parse it on I. Let's do cargo R, and let's pipe that out. Of course, it would do here. Okay, this must, I think this is correct. So we have what do we have here? We have our lights, we can ignore the spaces. We have our buttons, ignore the spaces. We have our junctions. Now we can finally create, okay. Okay, and it's gonna be I comma machine. It's gonna be this. Close that up. Then here we're gonna say machines equals input dot lines, input dot trim dot lines dot map. I guess let's do flat map line, and then we call parse machine. Okay, so in this case we don't really, we do We don't need to do that to return out the error. So parse machine on the line, and we can turn this into an OK, and then we can map over it and take the second one, and this will give us a list of machines, and then we can collect it into a vec. We can debug this out. Machines, but debug is not implemented for the machine, of course. Now let's do this. Derive debug. And then let's remove the ones, the parsers we didn't end up using. Oh, all of them failed. What pattern did we miss? Error code car. Why? We did parse lights and many parse button. Does that not matter much as a car? We can use a tag, I think. Is that the problem? So I think it was able to parse out the lights, but it failed to parse the buttons. So it was able to parse out the lights. Now before we get into this, let's see what our input looks like in here. Oh, in that case, I think I know what went wrong. Okay, so this has to be, instead of many parse, it has to be a separated list with space. I think that's true. But here the separator is space 1 and then the buttons. Okay, that seems correct. So let's get back here, flat map, and then I guess okay, nope, map the machines only, and then turn that into a okay, turn that into an option. Now let's run this again. Now we should be correct. Okay. Even parsing them took nearly an hour. Holy shit. Okay. So we now have the values correctly parsed, but I still don't have any idea how we should do this. Let's get cargo add ether tools. And I'm gonna go to docs.rs ether tools and permutations. But the thing with that with permutations, I think permutations is the closest thing we can use to do this, right? It's like something that's or Cartesian products. No, that's not it. But the thing is, it could end up being that we need to like press one of them multiple times, or press one of them 3 times. Like instead of taking 2 of them, like the shortest one could end up being like parsing one of them 2 times or something like that. So I don't think permutations is gonna get us that. We know the positions that are gonna need to be turned on, right? We know the positions that need to be turned on, and then we can maybe generate those positions and then look for them in the and then for maybe this could be an inner square loop. We can look at all of four buttoning buttons and like find the next one and find the next one and find the next one. Maybe what is 2? So 0, 2. So we turn yeah, okay. So in this, like this position got turned on and got turned off. Hello. I don't even have like an algorithm for this one. What we need to do is turn on the lights, and then these are the buttons that we're gonna need to press. So for example, if we press 0,2, that means we will start off with something like this. So we should start off with all of them being empty, because this is the target. This is the target we need to achieve. So when 0,2 is pressed, so the one at the 0 position and the one at the 0, 1, 2, the second position gets turned on. And then when we press 0,1 again, this one gets turned off, and then this one gets turned on. So we achieve the final state. So we want to find the shortest number, so the least button presses we need to do to find the final, to create the final list. But they did say some weird stuff like this. You can't toggle each button list which indicator light, where 0 means the first light, 1 means the second light, and so on. When you push a button, each list indicator turns on if it was off, or turns off if it was on. You have to push each button an integer number of times. There is no such thing as 0.5 presses. Nor can you push a button negative amount of times. I think if we get the positions of where we have the pounds, it's gonna be at 0. It's gonna be at 1 and at 2. So pound. So we need some kind of data structure where we can keep joining the button presses together, and it will cancel out the values that are the same, right? So for button presses, and then if we union them up, but I guess and then just keep track of the shortest one that produced 1,3, but that's assuming that we will be only needing 2 unions. We're gonna be needing some n number of unions. I don't know, like how many combinations are allowed? Are we allowed to press a button twice? So each button, so button wiring schematic like this, because you can push each button as many times as you like. However, to save time, you'll need to determine the fewest total presses required to exactly configure. How can we know that this is exactly the fewest one without exhausting all of the other possibilities? So I think we need, and I don't think there is we can do that, do we? Can we do that? However, button presses can do this because today's puzzle feels like it's gonna take some time. No, oh no. Let's ignore this. Target. Spend 1 hour, so let's do commit parse titan input. Okay, so since we know that we're gonna need to turn on 1,3, maybe we can now 1,2, maybe we can just look for one of the buttons being like pressing exactly 1,2. If that's the case, that we will return that, and then if that's not the case, we will find the one with the most of them turned on, and then we will look at the ones that will turn off that one, and then but that doesn't mean that we're going down the correct route. It could end up being that this one, for example, which one is the shortest one? The sad machine, so the one way to achieve this by pressing 0, 4, 0 and 1, 2, 3, 4 and 0. I have no idea. Literally zero idea. Is this gonna be like something like the union find thing they gave us like a couple of days ago on disjointed data structure? Is this gonna be following relationship or other? Don't think it is. This is not what we want. Literally zero idea. I think we just keep iterating over each one of them again and again. For each one, we iterate over like I think it's something like this for. I guess this all of that work needs to be done for a single machine. Wow. And then I guess let's say implement. So we can implement it here. We can say implement machine and say find one way to achieve this is by pressing the last 3 buttons. Find presses and button presses. It's gonna take itself and it is we're going to, so we have our target, like target, I guess it's gonna be self.lights touch known, and I guess target, let's say target no, let's say the start position. The start is gonna be something like this, so it's gonna be lights dot it's gonna be something like this, 0, till lights and dot repeat, maybe self dot lights down lane and dot repeat. Or for each one, map each one into a dot. I think this is what I'm thinking of. So this should be something like this. It should be dot repeat self dot lights dot length, which is the starting position for all of them. I don't feel like that's the correct position though. No, we want, this is what we want. We want to produce a late list equals no, we thought let's do this. Our target is this, the target is equals to self dot lights dot map. No, I guess dot iterate. No, dot iter. Yep, that's what it is. I guess we have to split them. Dot cars. That's what I want. Dot cars dot map. Enumerate, and then filter where x is equals to, no, yes, filter something like this, x is equals to dot, and then we can just map stop that, and then here where x is equals to that, and then map over them to find the position, the I, and then it will return the this is the target for each one of them. So debug target, I guess this needs to be collected. Yep, collected into Vec. Move that. Then look for let's say, I guess, let's say like count. Let's do that here. Let's do that here. Map over each machine and call m dot font button. Yep, we know that. So what the final list is gonna be a unique of, so until we reach the that 0,3 value. So we're gonna go for button in self dot button dot iterator. So, oh, okay, for each button that starts, so we're gonna need to use a hash set, or and then this this should be a hash set, right? I think it will be easier to compare it because I think this is also gonna be a hash set. So let's say what do we call this process? It's gonna start with a hash set, hash set from the current button, right? So, and then this is the thing we're gonna be using to compare. Okay, from button is not implemented for hash state. Oh, in that case we should add hash, or what was it? No, Rust implement hash. I don't think we can just derive it. You can do derive hash if I'm not mistaken. Yeah, derive hash. Maybe something like this. Is it because it's a maybe it's because it doesn't implement copy. Let's say copy, and I guess internal types also don't implement copy. Rest hash state. Sorry, but okay. So I guess process is gonna be a new hash state, and then for so in button we will process dot add, or I guess what is it? Is it push or is it insert? Okay, we will insert the button of process. We will add each press. Then this will be a hash set of user tools. Okay, so we initialize the process, and let's also initialize the actual list of buttons, which is gonna be starting with, so into button. I think this, I don't know, I think I need to derive clone on it. Let's do derive, no clone. Let's go here, and this is gonna start with the current button, and then let's say clone. So this is the initial condition, right? So we're gonna loop over, so while say so we will be indexing into the string using this let index equals but for each one, like, we're gonna be looping infinitely just so we can find the first one that finishes the first. Like, how do we even do that? Each one of them are gonna need to be recursing infinitely. Yeah, brute force might be, yeah, O in tuple times the first name, and bar because dynamic the state, but I have no idea how to find beef perfect. I know the lights to be turned on and off should be pressed an odd number of times, okay, and which are off should be pressed even number of times. Okay, that's a good hint. Yeah, me too. I have no idea how to solve it, but brute force might be. Yeah, and then the approach I'm currently doing would require me to loop infinitely until I find the mean one. There is no exit condition for me. There is no exit condition. I think this is not gonna work. It's not gonna work. I don't think it's gonna work. I was gonna loop until, like, we don't, like, hash state is not equal to target is not equal to process or something like that, but that assumes we will find it in this for this button. Yeah, it's gonna be annoying. I guess we can move this loop outside and initialize the process here, and also this one here, move it up here. We can keep on resetting it, maybe. Mute. While target is not equal to hashes, let's say I think this should be, there is some kind of algorithm, I don't know. I feel like today's part 2 is gonna be even harder. That's not gonna work. It'll still be the same loop. It's like I have nowhere. I'm like, this is not gonna go anywhere. Press 1,3 once. Press 2,3 once. The order we press them matters. So let's take let's try taking the order we press them matters. Let's try taking combinations with replacement, permutations, returns, if you are looking for permutations with replacement, what does they mean? What do they mean by permutation with replacement? Permutation with replacements are ordered managements of items where you can pick the same item multiple times, meaning the order matters. Yeah, AB is different from BA, and you put them back after selecting. Repeat n iterator k times multi-Cartesian product. We could be pressing the same one. We could also press the same. Do we even know like at least the maximum number of button clicks that would be required? I guess the absolute minimum, we know the absolute, we could kind of know the absolute minimum, but we don't exactly know the button presses. We only know the number of lights that need to be turned on, and that will give us, yeah, that will give us some information, right? So that we're trying to find what is the shortest combination that will result in a combination of that length. So at least it will be 2. No, at most it will be 2 for that case. Right, at most it will be 2. But for in that case, that then you're saying at most it could be 1 because we only have 1 position, but we needed 3 position. We needed by pressing the last 3 buttons. Yeah, and then that required 3. But okay. This is considering, so in the example we only need 2. We don't double, so you can push each button as many times as you like, but it's saying you could press all of them are being pressed once. It's like you could press once. In that case, I think if all of them are going to be placed only pressed once, we can take the permutation of the length of the list. Right? So if we take the, let's say, late buttons, and then self the buttons, not permutation, iterator permutations, stick self the button. Then collect what are we gonna see for this one? Debug buttons. It's gonna be a wake of buttons. Wake of buttons. Then cargo. Create a separatory. Even the permutations for this one generated are this many. Okay, so 0, 2, 3. Okay, that's one list. 0. Okay, in this case, let's do this. Let's try to do this. Let's do map each buttons combination equals target, maybe, I don't know, I can say self dot it's not gonna work. Let's say target dot no, let's do it hash or target dot with I guess equal should do the right thing, I think. And then for each button in buttons we need to add current dot insert not gonna work, and then check it for value. That's actually not gonna do it, right? Or it will do it, it will do it, it will do it. So, but when they appear for a second time, we should be removing them, right? So it should be something like this. If current dot contains the current value, then we remove it. Otherwise we insert it. If it contains it, that means we're seeing it for a second time, which means they're turning it off, and in that case we remove it. If we're seeing it for the first time, we add it. Hopefully now there will be something like target equals current still empty. To repeat and then I guess we can sort by that's not it. Yeah, I don't know. I don't think I'm gonna solve this one. Maybe we'll look for a solution, I guess, from somebody else. But yeah, I don't think I'm gonna do it. Entirely shortest. Oh, this is maybe what I want. The power set. Start with empty 1 2 1 2 1 3 2 3 1 2 3. Something like power set combinations. The for we can say permutation, and then for each permutation we can take the power set. Right? So maybe we can say we can have this. And then for each one of them we'll take the power set. Maybe this will work. But it's taking way too long. Even with the example, we're nesting too much stuff within each one. Fuck it. I'm gonna GPT it. I'm thinking of making a light with all the currently off, and then just simulate all the combo and keep checking if the current from real language. Or I might have been speaking Amharic because I'm from Ethiopia. Like pressing it once, blah 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 blah. Otherwise, we'll force it. Yeah, I don't know. I think we've been here for 1 hour and 30 minutes. No idea, and it's even part one. Yeah, that's time to use GPT. Say given a list of button presses with each button press list looking something like this. Let me just do this one. Which means a button press will turn on the lights at position 0 and 1. How can we find the shortest number? No, I think it's the least number of button presses that will result in a sequence of light arrays like 0, 1 being turned on. I'm storing the buttons in an array of integers. Yeah, I'm doing that too. So it's bad for me. It's a vague. Okay, so you joined all of them. But how do you know the count? If did you like join this all of these numbers together like in one giant list? But if you do that, how will you know like which ones are from which button press? I think I'm just using a nested vec U32, so I'm holding on to a vec of buttons, but if each button also contains like a vec of U32. This should actually be the lights it will affect, I guess. Bit masks, okay. It's saying represent the lights as a bit mask. Use BFS to find the minimum number of presses. Treat each light configuration as a node in a graph. Treat each light, okay. Nodes all possible states. bit mass from to the power of n minus 1. I think maybe this could be it. Adapting it to your router. Maybe this could be it, because we do have all that information here. So we do have the num lights, just gonna be self dot target, self dot lights dot range, and button masks, button lists, button targets, target lights, I mean. It's constructing for, let's try this out. Let's try doing this with the target first. Do like this, comment this out. So if input is yeah, makes sense, I guess. Drawing would make sense. Okay, for this could be a fold. Tell me, this could be a fold, so it can be accumulator, comma, x situation where just start with 0, and this is gonna say stuff like this. It mask with 1 x. So we have mapped them together. No. Okay then. It's creating a bit mask. Okay. But how does, okay, what's that? So let's see. Press print binary. Okay, colon B. Okay, yeah. Let me know if it works. If your brute force method will work. If it worked for you, but this is not correct. Yeah, I guess we're at 2 hours. I'm gonna have to leave now. We didn't solve today, I guess. We didn't solve Yasanyo, like the 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 puzzle on Monday. We solved it on Tuesday. We didn't solve it on Wednesday, so I guess we'll hopefully solve it tomorrow. But yeah, I don't think this is correct. It's saying do a masking operation, but I don't understand it. So it doesn't. I don't. I shouldn't really be following that. That yeah. It's because I don't understand it. It will. It does make sense, but I don't see how this will help us like do this. I guess it will help us apply the state to the easily apply the state to the to see easily apply the button press to see what will be the final state. But yeah, I think I'm gonna have to leave now. Yeah, we didn't solve it, and I haven't even come up with an idea. So if we had come up with an idea, we would spend some time implementing it. But the only thing we finished doing is parsing the input. At least we can say we did that. But yeah, see you guys tomorrow. Hopefully I'll see you guys tomorrow. I'm gonna be leaving now. Let's end the live stream. So yeah, let me end it. Goodbye.